Your brain is a powerful organ. It's always working tirelessly day and night, even when you're asleep. It's the control center of your body, managing everything from your heartbeat to your thoughts. But did you know your brain uses a ton of energy? It's like a high-performance engine that never stops running. Even though it's only about 2% of your body weight, it uses 20% of your daily energy. That's a significant amount for such a small organ. That's like a small car using the same amount of fuel as a giant truck. Imagine the efficiency and the power packed into that tiny space. Imagine your brain as a bustling city. Just like a city, it never sleeps. There are always lights on, cars moving, and people working, no matter the time of day. There are countless activities happening simultaneously, all requiring energy to keep the city alive and thriving. All this activity needs a lot of power. The electrical grid of a city is like the energy supply to your brain, constantly providing the necessary fuel to keep everything running smoothly. Your brain is the same way. Neurons are firing, signals are being sent, and complex processes are happening every second. It needs a constant supply of energy to keep all its amazing processes running smoothly. This energy comes from the food you eat and the nutrients you provide your body. What does the brain use all this energy for? Thinking, learning, remembering, and problem-solving are just a few examples. Every thought, every memory, every decision requires energy. Engaging in conversations, writing, and even daydreaming all consume energy. Your brain is constantly at work, even when you don't realize it. Your brain is the command center of your entire being. It's constantly making decisions, processing information, and coordinating actions. It's like the control room of a spaceship, managing every detail to ensure everything runs smoothly. Whether you're jogging in the park or a surgeon performing a delicate operation, your brain is in control, ensuring that your body functions optimally. So the next time you grab a snack, remember that you're not just feeding your stomach. You're providing essential fuel for your brain. When you feel hungry, it's a signal that your body, including your brain, needs more energy to keep going. By eating a healthy meal or drinking a nutritious smoothie, you're ensuring that your brain has the energy it needs to continue performing its incredible functions. So, take care of your brain, and it will take care of you. Our brains are precious. They need protection. That's where the blood-brain barrier comes in. Imagine a drawbridge guarding a castle. That's what the blood-brain barrier does for your brain. It's a tightly sealed border. It controls what can enter and leave the brain's delicate environment. This barrier is made up of special cells. They line the blood vessels in the brain. Think of them as tiny bouncers. They check everything trying to enter. They only let in things that are supposed to be there, like nutrients and oxygen. Why is this important? Because the brain is vulnerable. Harmful substances in the bloodstream could damage it. The blood-brain barrier acts like a filter. It keeps those dangers away from your brain cells. So, thanks to this amazing barrier, your brain can stay safe and sound. It's free to focus on its important job of running your life. Let's talk about neurons. These are the brain's messengers. They send signals throughout your body. Imagine them as tiny electrical wires connecting everything together. But how do these signals travel? Enter the salty banana. Picture a banana. The peel represents the neuron's membrane. Inside the peel is the salty banana itself. This represents the electrical charge inside the neuron. This charge is created by tiny particles called ions, the salt in our banana. When a signal needs to be sent, it's like a little message travels down the banana peel. This message changes the electrical charge as it zips along. This change in charge is like a domino effect, passing the message from one neuron to the next. So the next time you eat a banana, think of the amazing electrical communication happening in your brain. It's all thanks to those tiny salty bananas constantly sending messages throughout your body. Section 4. Seeing stars. The occipital lobe and visual surprises. The human brain is a marvel of biological engineering, and one of its most fascinating parts is the occipital lobe. Ever bumped your head and seen stars? It's a common experience that many of us have had at some point in our lives. That's your occipital lobe saying hello. This small but mighty part of your brain is responsible for processing visual information. Located at the back of your head, the occipital lobe is your brain's vision center. It's nestled right above the cerebellum and is crucial for interpreting the world around you. It receives signals from your eyes and interprets them into the world you see. Every time you open your eyes, light enters and is converted into electrical signals that travel to the occipital lobe. Think of it like a movie projector. Just as a projector takes a film reel and turns it into moving images on a screen, Your occipital lobe takes the raw data from your eyes and turns it into the vivid, colorful images you perceive. Your eyes are the lens, capturing light and sending it to the occipital lobe, the projector. This process happens in milliseconds, allowing you to see the world in real time. The occipital lobe then processes this information and projects the image onto your consciousness. It's an incredibly efficient system that works seamlessly most of the time. When you bump your head, it's like shaking the projector. The sudden jolt can cause a temporary disruption in the way your brain processes visual information. The sudden impact disrupts the normal flow of information. This interruption can cause the occipital lobe to misfire, sending out random signals that your brain interprets as visual phenomena. This can cause the occipital lobe to fire off random signals, creating those flashing stars or other visual disturbances. These visual disturbances are your brain's way of coping with the unexpected jolt. So while seeing stars isn't exactly pleasant, it's a reminder of the amazing way your occipital lobe works to create the visual tapestry of your world. Every scene you see, every color you perceive, and every movement you detect is thanks to this incredible part of your brain. The next time you marvel at a sunset or enjoy a beautiful piece of art, take a moment to appreciate the hard work your occipital lobe is doing behind the scenes. Our eyes come in many shapes and colors, but the occipital lobe treats all visual information equally, ensuring that everyone can experience the world in all its glory. The occipital lobe is a testament to the brain's complexity and its ability to adapt and respond to the environment. It's a small part of the brain, but its impact on our daily lives is immense. Whether you're reading a book, watching a movie, or simply gazing out the window, your occipital lobe is hard at work, making sense of the visual information and helping you navigate the world. So the next time you see stars after a bump on the head, remember the incredible journey that light takes from your eyes to your occipital lobe, and how this small part of your brain plays a big role in your perception of the world. Section 5. Busting myths. Your brain isn't powered by lightning. You might have heard that the brain works with electricity. This idea often conjures up images of lightning bolts or sparks flying around inside our heads. While it's true that neurons use electrical signals to communicate, it's not quite like the electricity powering your house, or the dramatic lightning strikes you see during a storm. Your brain isn't shooting off sparks or powering light bulbs. Instead, the electrical activity in your brain is much more subtle and controlled. Imagine a line of dominoes. This is a great way to visualize how neurons communicate with each other. When you tip the first one, it sets off a chain reaction. Each domino falls, transferring energy to the next. This chain reaction is similar to how electrical signals travel through neurons in the brain. Each neuron passes the signal to the next, creating a wave of activity. That's more like how electrical signals work in the brain. It's a series of small, controlled steps, rather than a single, powerful burst of energy. The movement of ions across neuron membranes creates a small electrical potential difference. This difference is what allows neurons to communicate with each other. This difference, though tiny, is enough to trigger the next neuron in line. It's a delicate balance that ensures the proper functioning of our brain. It's a highly controlled and delicate process, nothing like the jolt of a lightning bolt. Scientists study this process in great detail to understand how our brains work. So, while we often use electrical terms to describe brain activity, it's important to remember that it's a much more subtle and intricate form of electrical communication. The brain's electrical activity is more about precision and coordination than raw power. Think dominoes, not lightning storms. The next time you hear about the brain's electrical activity, picture a carefully orchestrated sequence of events, not a chaotic burst of energy. This understanding helps us appreciate the complexity and elegance of our brain's communication system. The brain's electrical signals are essential for everything we do, from simple movements to complex thoughts. Each signal is part of a larger network, working together to create our experiences and actions. Understanding this process can also help us in medical science. By studying how these signals work, researchers can develop treatments for neurological disorders and improve brain health. So the next time you think about your brain, remember that it's not powered by lightning. It's a sophisticated system of tiny electrical signals, working together in harmony to make everything you do possible. This intricate dance of electrical signals is what makes our brains so remarkable. It's a testament to the incredible complexity and efficiency of our nervous system. So, let's appreciate the subtlety and precision of our brain's electrical activity. It's not about dramatic sparks or lightning bolts, but about the delicate and precise communication that makes us who we are. In conclusion, while the brain does use electrical signals, it's a much more controlled and intricate process than the dramatic imagery of lightning. It's a beautiful and complex system that powers our thoughts, actions, and experiences.